Welcome friends once again. So now we are going to make a change here. This will be certain differentiation questions which are to be used in kinematics, and in this video I'll be making the total video in English because certain students have asked me for Hindi medium. I have given them a Hindi video. Now this is going to be exactly in English video I'm giving you. Okay, now we have already studied the displacement is given and you want velocity. You have to differentiate it once, and if you have been given velocity, you differentiate, you will get the acceleration, and vice versa. If you integrate the acceleration, you will be getting the velocity, and if you integrate the velocity, you will be getting the displacement. So let's see the first question here. See that velocity and acceleration of the particle to be found out, knowing that the displacement is given. So different times are given, 2, 5 and 3 seconds, and the displacement is given as x equals to 2 minus 6t plus t squared. We very well know when we differentiate displacement we will get the velocity expression. So that's what the first thing we do. V is equals to d by dx by dt, which is d by dt of 2 minus 6t plus t square. So we have basically taken the whole expression over that. You know derivative of 2 is constant, derivative of minus 6t is negative 6, and for t square it is 2t. Now if I put the value of 2 seconds, 5 seconds and 3 seconds in t, because t has been given as 2, 5 and 3, then I'll be getting the velocity at respective timings. So let me check it out. Velocity at t equals to 2 is negative 2 meter per second, because I have placed t equals to 2. In the second case I'll put minus 6 plus 2 into 5 for 5 seconds and then for 3 seconds. So if we can find the velocity is varying every time whatever we are doing it, that simply means velocity is not constant because it is having a function of t. That means it is varying. If the function of t is not there, or the expression of t is not in the velocity expression, we will say it's a constant velocity. Now we have to differentiate once again to get the acceleration, because the original question was to find the velocity as well as acceleration. So we differentiated once again. See, now I'm getting the dv by dt. We write as dv by dt, or in fact even we write as d2x by dt2, or somebody call it d square x by dt square. Now this is 2. 2 means it is not containing any expression for t. That means whether it's t is 2 or 5 or 3, anytime this is going to be a constant. So what is this? This is acceleration. So we will say it is uniformly accelerated motion, because you can see the t is not occurring in the second derivative. That simply means that this acceleration is now constant. You can take it as a thumb rule also, that the expression till t square you are going to have a uniformly accelerated motion. Beyond t square, let it be t cube or t4 or anything, in that case the acceleration will not be uniform, because the only thing which has come till second derivative is the square function. Let's see one more. Here he is saying, just read the question, and here now we start the same method. If you know the question, have you understood, then in that case just pause the video and try to do it yourself. You have to just pause the video and try to do it yourself. However, if you are not understanding what to do, let me give you the hint and then you can try it out. You very well know he is saying displacement is given as a given expression. He is saying find out the velocity. Will it be 0? So first thing is to get the expression for velocity. You know, after differentiating the displacement we are going to get the velocity expression. Once you get velocity expression, equate that to t equals to 0. Equate that to 0, you will get the value of time. So we'll come to know at which time my acceleration becomes 0. And after that, sorry, my velocity becomes 0. And now place the same time for the acceleration expression. Because ultimate my question is find the acceleration when velocity is 0. The first thing we try to find when velocity was 0, then we are going to put in the acceleration expression. You have right now understood. Please try to do it again by pausing the video. And for those persons who have not understood anything, let me do it. See, x equals to given as minus t cube plus 48 plus 6. We take the expression for the velocity, which comes out to be negative 3t square plus 48. And the original thing was when this velocity is 0, find the acceleration. So first thing is to make this expression equals to 0. For v to be 0, we make this expression equal to 0. Now we are getting two values of t, plus minus 4. Remember, negative 4 we are not going to take because time does not move negative frame. So now t equals to 4. But what to do with t equals to 4? We have to place the value in the expression for the acceleration. So what do? You first get the acceleration. So I differentiate once again the velocity dv by dt. I get minus 6t. Now since now you can say this expression contains t, that means acceleration is depending on time. It is not a uniform acceleration. And by obviously because it was t cube in the displacement expression, so it has to be depending on time. Now time is given to us as 4. Take this 4 and we get the value negative 24 meter per second square. I hope this is clear to you now. Okay, now one more question. Just read the question. If you have understood, you can try it out. Here what is saying? He is saying find the displacement and velocity of the particle when acceleration is 0. In the previous question, he wanted to get acceleration when velocity is 0. Now he wants displacement as well as velocity of the particle when acceleration is 0. So first thing is to get the acceleration. And you know what is acceleration? The second derivative of displacement. So we have to differentiate it twice. The one who have understood, please try to do now, again pausing the video. And for the students who have not understood, I'll just explain it now in detail. This is given as s or x. We differentiate it. It gets 3t square minus 6t. Now we differentiate once again. Now he wants when acceleration is 0, that time you want displacement and velocity. So 6t minus 6 must be equated to 0. For acceleration to be 0, we get the value t equals to 1. Now I'm already having displacement expression, already having the velocity expression, which is 3t square minus 6t. I'll just have to put the value of t equals to 1 second over there. I put the value v in t in 3t square minus 6t. I get negative 3 meter per second, and I get s as t cube minus 3t square plus 2. It becomes 0. So after 1 second, my displacement is 0. That means somewhere velocity has come, the body has come back to original position. I hope now this will be clear to you. Okay. One more we are going to give you. Now see this question. Now this will give you certain new things. It's a different type of question. See what is he saying? He is saying displacement has been given as an expression. Now since expression is given in terms of t cube, we know it should not be a uniformly accelerated motion. It is non-uniformly accelerated motion. That means the acceleration must have t as a function also. Now he wants position, velocity and total distance and acceleration. I repeat, position, velocity, total distance and acceleration at t equals to 5. Now let me tell you, position, straight away put t equals to 5, velocity, put t equals to 5 in the velocity expression, acceleration also the same way. But distance wise you have to understand something new. I'll just explain you now. If you have understood, please carry on with the question. For the other people who have not understood, let me give you a hint once again. See, for S we have given 25 straight away because position is the first thing and you know it is at after 5 seconds. You have to just put the 5 there. You have to find the velocity, just differentiate it and get velocity. Come on, let's differentiate. What do we get? 3t square minus 12t plus 9. I'll put the value of 5 seconds. What do I get? An acceleration also there. So acceleration is 18 meter per second square. And I want velocity also at 5. I'll get the velocity at 5. Now, remember one thing. Velocity at 5, I forgot to put it there. You can put 5 square, 25 times 3, 75 minus 60, 50. This will be 24. I have just left out the calculation for the velocity. It will be 24. Now, the total distance. Now, see, total distance will not be 25 because for any journey, total distance will, at times when the velocity becomes 0, the particle reverses the direction. Supposing I throw a body upward, so it goes, let's say 20 meter high, then it comes back to me, then displacement wise it is 0, though it has gone 20 meter high and then 20 meter down. Displacement wise it is 0, but distance is 40. He is asking the distance now. So for distance you will always have to calculate at what points the velocity has become 0. That means those many times the path has been changed. See, I'll take the velocity, I'll equate to 0. That means I get t equals to 1 and t equals to 3. That simply means at 1 second and 3 seconds the particle is changing the direction. Let me show it here. So now 1, 3 second was there. So we have to find at 0, at 1, at 3 and 5. So I get t equals to 1 at 9 meters. That means after 9 meters the velocity just changes the direction. Now I put t equals to 3. I get 5 meters. That means after, when it's coming back, that's why you can see it reaches at 9, comes back at 5. Starts from 5, goes till 9, come back to 5 again. So now during this journey, if you say from 0 to 3, it has already distance of 10 but displacement is 0. It has not traveled. Right? Similar. That is why we have to take 0, 1, 3 and now we'll take a 5 also. When I put 5 it becomes 25 meter, which we have done at the starting. The position was 25 only. Now actually what is the distance now? Let's understand what's happening. The particle has taken a path such that twice it has changed the direction. This has been the path. From 5 to 9 in 1 second, then 9 to 5 back in 3 seconds, then from 3 to 25, 3 to 5 seconds, it is from 5 to 25. So total distance over here covered here is going to be like this. 20 plus 4 plus 4. Because from 5 to 25 it's 20, then 5 to 9 4 and 9 to 5 4. This is the distance. So remember, whenever you have been asked a distance, you have to always try to find whether the velocity has ever been 0 within that interval or not. If the interval is there, you are getting some point. That means you have to break the S in those many parts. That's what we did here. And this is a question of good level. Right? This question might come to JE level. So, I hope you have understood the basic fact. And now, we'll meet in the next video. I'll make a separate video for the Hindi, for the English, for your requirement. Thank you.